Hello everyone, my name is Nivas and I'm of Computer Science Engineering branch of B section. So my ID number is 21951A0588. So I'm making a Tech Talk PPT on the subject Basic Electrical Engineering, shortly called BEE. So the topic of this PPT is blast tube cooling for aircraft. So let's discuss about it. So blast tube cooling for aircraft generators. So let's dive into the slides. Abstract. So let us start with the abstract. Blast tube cooling has been a major factor obtaining the phenomenal outputs of modern aircraft generators from a small weight of material. This subject, in spite of its importance, seems to have been neglected in technical literature, and as a result, the fundamental principles do not seem to be yet well understood. Because of this lack, the subject has often appeared to be more involved than it is actually. It is generally understood that the amount of air flowing through a given generator depends upon the pressure differential variable across the generator. And it is also well understood that the amount of pressure available from the blast tube depends upon the amount of air drawn by the generator. Because of this mutual interdependence, flight tests are today generally taken with a specific generator called blast tube. And it seems to be generally felt that it is necessary to test each different combination of generator and blast tube. Just as Ohm's law enormously simplified the circulation or the calculation of electric circuits, so can the calculation of blasting can be simplified by the use of similar concepts, which will be defined, explained, and used in this paper. This line of attack clarifies the fundamental principles involved, makes it necessary to run only one series of tests on any given blast tube. The one series of tests on any given generator, it is not necessary to test each and every combination of generator and blast tube. So going to the next slide. What is an aircraft basically? So an aircraft is a vehicle or a machine that is able to fly by gaining support from the air. So it encounters the force of gravity by using the static lift or by using dynamic lift. Here static lift or dynamic lift is done by the aerofoil of the aircraft. Further we'll discuss about the aerofoil of an aircraft. So, or in a few cases, the downward include aeroplanes, helicopters, airships, including blimps, gliders, paramotors, and hot air balloons. This is how an aircraft looks like. As we can see in this picture, you can visualize that this is a basic huge aircraft that is one of the biggest birds flying in the skies. These aircraft basically run or fly on the basis of engines. So coming to the engines, these are not normal engines, means not ordinary engines. These are type of engines which produces large amount of energy and thrust to lift a huge body for transportation and also for other purposes. Thus, these huge engines do produce a lot of heat and pollution too. But ever thought of how the engine sustain a drastic amount of heat from melting of the parts? So today we are here to discuss about this topic to get more information. So what is way to avoid jet engine heat? So there is an alternative to avoid this type of situation, which is called blast tube cooling for aircraft generators, which is a mechanical process in which till to date it has been a successful method to cool down jet engines, aircraft generators, and all other heat production parts of the aircraft and etc. So why doesn't jet engine generator produce more amount of heat? So coming to that point, so basically a jet engine generator produce a large amount of heat due to the mixture of air and fuel catches fire. Here fuel is a type of fuel which is not an ordinary fuel. We'll come and we'll discuss about it later. This provides a high temperature, high energy flow. The fuel burns with the oxygen in compressed air, producing hot expanding gases. In the modern aircrafts, a highly flammable fuel is called jet fuel, which causes more heat in the generator. This fuel is a refined kerosene-based fuel. So, to avoid such heating, a blast tube cooling for aircraft generators is the best method to use in this present world. So, let's discuss more about it. As we can see that in this picture, we can visualize that this is a very huge jet engine. This is how the interior of the jet engine looks like, and this is how the complexity of an engine is like. So let's go to the another slide. Blast tube cooling for aircraft generators. A blast tube is a handy and a small part in the engine generator, which are present in many numbers as a cooling part of the engine. It takes the cool air from the outside according to the aircraft speed and lets that cool to pass through the main part of the engine and avoids rapid engine heating and starts cooling the engine to sustain for longer flights. So as we can see that this is the blast tube, which is a very small part but plays a very major role in cooling big machines. This is a small part in the aircraft which is present in numerous quantity to cool engine, and these blast tubes are placed around the engine entrance, which blasts the cool air from outside and blasts on the engine to cool and maintain the engine at a safest temperature. Process of cooling. So in the above image, as we can see that, you can observe that many pipes, which are, these are the blast tubes in this diagram. These are number of blast tubes. As we can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Around 10 blast tubes. It depends upon how big the engine is, how big a jet engine is. It depends upon that. These are all the blast tubes are placed in entrance of the engine. As we can see that it is placed in the entrance of the engine and takes the air from outside in a systematic way and passes the cool air to the engine, and then engine heat, it controls the engine heat and controls the combust heat produced by the engine. So this is how a blast tube works for cooling a jet engine. If there were no blast tubes, for an instance, if there were no blast tubes, then the engine would have got overheated and spoils and melts major parts of the engine, and engine blasts into pieces due to whole fuel get ignited in large amount. When an engine doesn't have cooling system like blast tube or any other mechanical part, then engine automatically gets overheated, melts almost all major parts and gets turned off. And when it, in case if it won't get turned off, then the whole fuel will be ignited and the whole aircraft will be bursted into pieces. So this is how the advantage of blast tube. So thanks for blast tube. How does cooling takes place? The burning process in a gas turbine engine is continuous, and nearly all of the cooling air must be passed through the engine. If only enough air were admitted to the engine to provide an ideal air or fuel ratio of 15:1, internal temperatures would increase to more than 4,000 degrees Fahrenheit. In practice, a large amount of air in excess of ideal ratio is admitted to the engine. The large surplus of air cools the hot sections of the engine to accept temperatures ranging from 1500 Fahrenheit to 2100 Fahrenheit. Because of the effect of cooling, the temperature of the outside of the case are considerably less than those encountered with the engine. The hottest area occurs in and around the turbines. Although the gases have begun to cool a little at this point, the conductivity of the metal in the case carries the heat directly outside the skin. Aircraft engine cooling systems. As we see that there is an excessive heat is always undesirable in both reciprocating and turbine aircraft engines. If means were not available for its control or elimination, major damage or complete engine failure would occur. Although the vast majority of reciprocating engines are air-cooled, some diesel liquid-cooled engines are being made available for light aircraft. As we can see in the figure 1, this is a diesel liquid-cooled aircraft engine. In a liquid-cooled engine, like diesel liquid-cooled engine, around the cylinder are water jackets. As we can see here, these are water jackets. The whole part outside is covered with water jackets, in which liquid coolant is circulated and the coolant takes away the excess heat. As we all know that in daily life, we use liquid coolant in cars, bikes, not in bikes, but in trucks and in all other automobile vehicles. As we all know that coolant will be in a simple liquid state. Even flights also are, flight engines are also cooled with coolant, which is also used here. The excess heat is then dissipated by a heat exchanger or a radiator using airflow. Turbine engines use secondary airflow to cool the inside components and many of the exterior components. This is how airflow saves the major and the sensitive parts inside the engine, so that to prevent melting from they won't overheat or they won't melt from the engine's heat. So this is how an aircraft engine cooling system in diesel liquid cooled aircraft engine works. Let's go into the next slide. Reciprocating engine cooling systems. An internal combustion engine is a heat machine that converts chemical energy in the fuel into mechanical energy at the crankshaft. It does not do this without some loss of energy. However, and even the most efficient aircraft engines may waste 60 to 70% of the original energy in the fuel. Unless most of this waste heat is rapidly removed, the cylinders may become hot enough to cause complete engine failure, as we discussed earlier. Excessive heat is undesirable in any internal combustion engine for 3 principal reasons. Those 3 principal reasons are: it affects the behavior of the combustion of the fuel or air charge, fuel charge or air charge. Second point, it weakens and shortens the life of engine parts. It impairs lubrication. So these are the 3 factors which are reciprocating engine cooling systems, which affects engine cooling systems. So to the next slide. Reciprocating engine cooling system, the same. If the temperature inside the engine cylinder is too great, the fuel air mixture is preheated and combustion occurs before the desired time. Since premature combustion causes detonation, knocking, and other undesirable conditions, there must be a way to eliminate heat before it causes damage. There is an image for an overheating engine. This is how an overheated engine looks like, which is a jet engine, which is not a normal engine, which is a jet engine. You can see that almost this part has turned into an reddish orange color, which indicates that a jet engine has got overheated. This is how factors reciprocate engine cooling systems. Going to the next slide. Amount of combustion in engine. 1 gallon of aviation gasoline has enough heat value to boil 75 gallons of water. Thus, it is easy to see that an engine that burns 4 gallons of fuel per minute releases a tremendous amount of heat. About 1/4 of the heat released is changed into useful power. The remainder of the heat must be dissipated to that it is not destructive to the engine. In a typical aircraft power plant, half of the heat goes out with the exhaust and the other is absorbed by the engine. Circulating oil picks up part of this soaked in heat and transfers it to the airstream through the oil cooler. The engine cooling systems takes care of the rest. Cooling is a matter of transferring the excess heat from cylinders to air, but there is more to such a job than just placing the cylinders in the airstream. A cylinder on a large engine is roughly the size of a gallon jug. Its outer surface, however, it is increased by the use of cooling fins so that it prevents a barrel-sized exterior to the cooling air. Such an arrangement increases the heat transfer by radiation. If too much of cooling fin area is broken off, the cylinder cannot cool properly and a hot spot develops. Hot spot means, as we have seen in the earlier slide, it turns into orange reddish color, which is called as hot spot develop. Hot spot at a particular part. Therefore, cylinders are normally placed if a specified number of square inches of fins are missing. So this is how amount of combustion happens in a jet aircraft engine. Cylinder baffle and deflector system. Cowling and baffles are designed to force air over the cylinder cooling fins. As we can see in figure 2, this is cylinder baffle and deflector system. The baffles direct the air close around the cylinders and prevent it from forming hot pools of the stagnant air while the main streams rush by unused. Blast tubes are built into the baffles to direct jets of cooling air onto the rear spark plug elbows of each cylinder to prevent overheating of ignition leads. This is how a cylinder baffle works in a jet engine, which takes air in unusual way, but it decreases the space around this part so that the air gets closer and gets more effective force to blast on the cool air to blast on the engine so that it gets instant cooling on the engine. So this is how a cylinder baffle and a deflector system works. Next slide. Aircraft to be maintained in minimum temperature. Maximum temperature is also dangerous. Well, minimum temperature has to be maintained. If there is no minimum temperature in the engine or in an aircraft, so then there might be a technical issues or mechanical issues where engine won't be working properly. If there is no minimum temperature, the heat required to the engine, then the engine won't start properly. Engine issues may rise. So that is why minimum temperature is also maintained in the aircraft engine, which is necessary. An engine can have an operating temperature that is too low for the same reason that an engine is warmed up before takeoff. As we discussed, it is kept warm during flight. Fuel evaporation and distribution and oil circulation depend on an engine being kept at its own optimum operating temperature. The aircraft engine has temperature controls that regulate air circulation over the engine. Unless some controls are provided, the engine could overheat on takeoff and get too cold in high altitude, because on the surface of the earth we can see that the temperature rises up to 60 or 70 degree Fahrenheit. When the altitude increases, when an object gets to an extent in the altitude, then the temperature will be too cool that it could cool or freeze engines. So for defrost, for not getting cooled, a defrost system is found so that the engine won't get frozen faster in higher altitudes. Unless some controls are provided, the engine could overheat on takeoff and get too cold in high altitude. High speed and lower power letdowns. So this is how the minimum temperature of an engine is maintained at different parts. How the temperature is going to be like in an engine at different areas, different sections, different parts of an engine. So we could see that the cool 0 to 2, the cool air enters, and this is the turbine. This is a section of turbine. Here, the cool air decreases a bit, and here from here the generator, the some hot air will be produced, and then from here, from this blast area, we'll get a lot of high temperature, which makes the engine hot. So going on to the next slide. Cowl flaps. What are cowl flaps? The most common means of controlling cooling is the use of cowl flaps. In figure 3, as we can see that these are cowl flaps. Cowl flaps are those which are under beneath the engine part or any near any part of the flight or any part of the flight, because these are used to cool engine. This is one of the method to cool engine. These flaps are opened and closed by electric motor given jack screws, by hydraulic actuators, or manually in some flights. When extended for increased cooling, as we have discussed that these are used for extended cooling and instant cooling, the cowl flaps produce drag and sacrifice streaming line for the added cooling. On takeoff, the cowl flaps are opened and only enough to keep the engine below the red line temperature. Heating above the normal range is allowed so that its drag is as low as possible. During ground operations, the cowl flaps should be opened wide since drag does not matter and cooling needs to be set at maximum. Cowl flaps are used mostly with older aircraft and radial engine installations. As we can see that this is a cylinder baffle and deflector system. This is similar to it, but this cylinder baffle and deflector system is placed on the exterior part of the engine, of the main engine, of the jet engine, where here, which is a propeller plane, it is placed beneath the engine, means beneath the fuselage. So these are two mechanical parts which are used for engine cooling, which are also called cowl flaps. Some aircrafts use augmenters to provide additional cooling airflow, where we can see in figure 4. This is known as augmenter. Each nacelle has 2 pairs of tubes running from the engine compartment to the rear of the nacelle. This is the nacelle. This part is the nacelle. The exhaust collectors feed exhaust gas. These red arrows are called as the exhaust gas into the inner augmenter tubes. These are inner augmenter tubes. The exhaust gas mixes with air that has passed over the engine and gets it to form a high temperature, low pressure, jet-like exhaust. This low pressure area in the augmenters draws additional cooling air over the engine. Air entering the outer shells of the augmenters is heated through contact with the augmenters tubes, but is not contaminated with exhaust gases, which are not contaminated with the red lines, which are exhausted gases. The heat air from the shell goes to the cabin heating, defrosting, and anti-icing. So earlier we have discussed that while traveling in high altitudes, the engine gets frozen because of low temperature at high speeds. So to not froze, to be not frozen the engine, these augmenters are used to take the exhaust gas and pass around the engine so that it maintains a specific required temperature. Engine cooling and exhaust systems. As shown in the figure 5, this is engine cooling and exhaust system of a basic propeller, uni-propeller engine. The engine is pressure cooled by air taken in through two openings in the nose cowling. These are the two openings of the nose cowling, as we have seen in the earlier slides. This is the part where the opening is. From here, the air will be entered, the engine will be cooled in this exhaust system. Two openings in the nose cowling, one on each side of the propeller spinner. A pressure chamber is sealed off on the top side of the engine with baffles properly directing the flow of cooling air to all parts of the engine compartment. Warm air is drawn from the lower part of the engine compartment by the pumping action of the exhaust gases through the exhaust ejectors. This type of cooling system eliminates the use of controllable cowl flaps and assures adequate engine cooling at all operating speeds. This is an engine cooling exhaust. This is one of the methods, and earlier methods were also one of the methods to cool an engine. And in all these methods, blast tubes are playing the main role to cool the engine. Small aircraft cowl flaps, which are used for small aircrafts. The controllable cowl flaps provide a means of decreasing or increasing the exit area at the rear of the engine cowling. As we can see in the figure 6, this is a small engine, a small aircraft engine. Here we can see the cowl flaps, which lets the cool air enter into the engine bay and then try to cool it. Closing the cowl flap decreases the exit area, which effectively decreases the amount of air that can circulate over the engine fins. The decreased airflow cannot carry away as much heat. Therefore, there is a tendency engine temperature tends to increase. Opening the cowl flaps makes the exit area larger. The flow of cooling air over the cylinders increases, absorbing more heat, and the engine temperature tends to decrease. Good inspection and maintenance in the care of the engine cooling system aids in overall efficient and economical engine operation. Maintenance of engine cowling. The maintenance of the engine cowling. Of the total ram airflow approaching the airborne engine nacelle, only about 15 to 30% enters the cowling of provide engine cooling. The remaining airflow over the outside of cowling. Therefore, the external shape of the cowl must be fed in a manner that permits the air to flow smoothly over the cowl with a minimum loss of energy. The engine cowling discussed in this section is a typical of that used on many radial or horizontal opposed engines. All cooling systems function in the same manner, with minor engineering changes designed for specific installations as depended on the particular jet engine or particular aircraft, means the size. The cowl is manufactured in removable sections. The number varies with the aircraft make and model. The installation shown in figure 7 contains two sections that are locked together when installed. So this is a differential air cooling technique. This is how it works as shown in the diagram. This is how the maintenance of engine cooling has to be done in the aircraft. So let's move on to the next slide. Engine cylinder cooling fin inspection. The cooling fins are of the utmost importance to the cooling system since they provide a means of transferring the cylinder heat to the air. Their condition can mean the difference between adequate or inadequate cylinder cooling. The fins are inspected at each regular inspection. Fin area is total area, means both sides of the fin. Both sides of the fin is called as total fin area. Exposed, which is exposed to air during the inspection. The fins should be examined for cracks and breaks, so that it does not have any cracks or breaks. When it is at higher speeds, if fins have any cracks or breaks, they're going to get separated from the main part or fuselage, so that the whole aircraft gets destructed. As we can see in the 8th figure, small cracks are not a reason for cylinder removal. These cracks can be filled or even sometimes stop drilled to prevent any further cracking. Rough or sharp corners on fins can be smoothened by outfiling, and this action eliminates a possible source of new cracks. However, before reprofiling cylinder cooling fins, consult the manufacturer service overhaul manual for the allowable events. This is how the overall maintenance is done and the inspection on the engine cylinder cooling. This is how people take much care, utmost care on engine cooling systems, because they play a major role for the aircraft to sustain longer periods. So this is how a cylinder head and fins look like. Moving on to the next slide. Exhaust gas temperature indicating systems means the systems which indicate the amount of gas, the amount of combust gas or exhaust gas is at what temperature. So the exhaust gas temperature indicator consists of a thermocouple placed in the exhaust stream just after the cylinder port, just beside the cylinder port, like here. EGT, exhaust gas temperature, probe mounted in exhaust tank here. So as we can see here in figure 12, which is an exhaust stack, it is then connected. This is then connected to the instrument in the instrument panel. This allows for the adjustment of the mixture, which has a large effect on engine temperature. By using this instrument to set the mixture, the engine temperature can be controlled and monitored. This is the pipe which is connected to the instrument panel. So instrument panel indicates the pilots that the combust air produced or the exhaust air produced is at particular temperature. When it is normal, they don't have to worry about that. But when the temperature is extremely high, then the pilots could take any precautionary steps to control the exhaust or combust temperature gas to maintain the engine cool. So moving on to the next slide. This is how an exhaust gas EGT probe works in an aircraft. So that's all for this blast tube in an aircraft. I hope everyone understood about this PPT, and thank you everyone for listening this PPT. Conclusion. So here we can conclude that not only jet engines require engine cooling, but also other automobiles require engine cooling for long sustainability. So this is how an engine cooling process is important in our daily commuting life. Thank you all. Thank you.